All right, hello people watching this video. Some of you I've explained this already to a little bit, but you will need to pay particular attention to example 3 because that's going to be the hard part. So you might be able to figure out example 1, example 2, but example 3 is the hard part. So before we start talking about operations, which is add, subtract, multiply, we won't divide, but add and subtract and multiply are the operations. We need to talk about different sizes of matrices. Okay, ready? This is a 3 by 3 matrix. There are 3 rows and 3 columns, yeah? 3 rows, 3 columns. Make sense? So this is a 3 by 3. Write this down. It goes row by column, not column by row. C-O-L-U-M-N. There you go. Row by column. Okay?
I still don't know what a row was.
So rows go
This way,
right? A row is this way. A column goes up and down, like a column or like a pillar on a building, right? A column or a pillar on a building goes up and down. So this one has, actually there's 4 because there's a fraction in there. There's 4 rows and 1 column, so this is a 4 by 1 like it says, right? Make sense? Okay, that's what those are. All right, when we're adding and subtracting, you can only add and subtract if they are exactly the same size. So how big is A?
3 by 3.
A 3 by 3. How big is B?
3 by 3.
So I can add them together, okay? They want us to do A plus B. I'm going to do that over here. A plus B. If I add A and B together, it will be a 3 by 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? Then I'm going to do A minus B, which will also be a 3 by 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, blah, blah, blah. Okay? All right, if I take A plus B, you're just taking each cell and adding it to the other cells.
8.
So 3 plus 5 is 8. 2 plus a negative 6
-4.
is negative 4. Negative 5 plus 2
-3.
is negative 3. 6 plus 4 is 10. 1 plus 5 is 6. 7 plus negative 4 is 3. Negative 2 plus 1 is negative 1. 0 plus negative 1 is negative 1. 5 plus 0 is 5. Was that really fast? What? That was good?
Yep.
Okay. All right, then subtracting. Okay, same thing again. 3 minus 5. Negative 2. 2 minus a negative 6 is positive 8. Negative 5 minus 2, negative 7. 6 minus 4 is 2. 1 minus 5, negative 4. 7 minus a negative 4, 11. Negative 2 minus 1 is negative 3. 0 minus a negative 1 is positive 1. And 5 minus 0 is 5. That's A plus B and A minus B. Not too bad, right? Pretty good, pretty good. Okay? All right, then we're going to talk about multiplying, but we're not multiplying 2 matrices together yet. They're saying this is what A is, or find 3A. Okay? A is a 3 by 3. 3A is also going to be a 3 by 3, but how do you find 3A?
Just take all the numbers.
Take all the numbers times 3. So 3 times 3 is 9. 2 times 3 is 6. Negative 5 times 3 is negative 15. Then we go 18, 3, 21, negative 6, 0, 15. Did I do that right? Yep. That's easy. We like this. Yeah, we like this. Okay. All right. Good? On the front side? The back side is going to be the hard part, and it's really not even that hard. I kind of find these fun. Like this is just like brainless, mindless work right here. Okay? So you have to make sure that you have the correct sizes when you're multiplying. I said adding and subtracting, you can only add and subtract them when they are the same size. That is not the case for when you are multiplying. Here's the rule for multiplying. Okay, let's write out. A is what by what?
3 by 2.
That.
2 by
Rows
3.
and then columns. So it is 2 rows by 3 columns. So A is a 2 by 3. Write that down.
That's a 3 by 2.
B is a 3 by 2. And C is
A 2 by 2.
a 2 by 2. Okay? All right, they are wanting us to find. I'm going to write AB over here. AB. Then they want us to find BA. Then they want us to find AC and CA. Okay? These are the 4 things that they're wanting us to do. You cannot always... No, A, B, and B, A are not the same. I'll show you the difference between the two, okay? A, B, B, A, all right? If we do A and B, I'm going to recopy A here and B here, okay? It's a really good idea to recopy them because then you get them in the right order. 2, 0, 1, negative 3, 5, 8. This is the part that you need to pay attention to. A, B. A, B. First of all, we need to see if these are even compatible. Can we even multiply them together? They're not the same size, right? But here's the rule. A was a 2 by 3. B is a 3 by 2, yeah? Mm-hmm. They only can be multiplied if these two numbers that are in the middle are the same.
That is weird.
That is weird. I'll show you why. You'll see why when we start to multiply them, okay? So those two numbers are the same. Yes, we can multiply them together. And when you cancel them out, left over would be a 2 by 2. Do you see that? So as a result, if I take a 2 by 3 times a 3 by 2, I'm going to end up with a 2 by 2. Yeah? Make sense? Okay? Just leave that, and we're going to multiply them here in a second. Okay? If I take B times A, let's copy B. B was a 2, negative 3, 0, 5, 1, 8. A, 3, 1, 2, negative 1, 0, 4. If you recopy him, he looks like that. Okay?
Oh.
And they have to go in that order. B is a 3 by 2.
And a 2 by 3.
And A is a 2 by 3.
So
Can you multiply them?
Yeah.
Yes, the middle two pieces are the same, but when you multiply them, you will end up with a 3 by 3. So, is AB the same as BA?
No.
No, they won't even be the same size, right? Won't even be the same size. All right, let's look at AC. Okay, A, 3, 1, 2, negative 1, 0, 4, and C is 1, 0, 3, negative 1. Here we go. What's the size of A?
It doesn't work.
2 by 3. C, 2 by 2. Can you multiply them together?
No.
No. So this can't even be multiplied, and then you just say no, and then you're done. I like that one. All right? Okay, let's look at CA. So CA is writing them backwards. 1, 3, 0, negative 1. And then 3, 1, 2, negative 1, 0, 4. Okay? This one is a 2 by 2. And this is a 2 by 3. Yeah, it does work. The 2's are in the middle. So you end up with a 2 by 3. So AC and CA obviously are not the same because one of them you can't even do, the other one you can. Okay? All right, now let's actually multiply them together. Ready? This is the hard part. That's the easy part. This is the hard part. AB is the first thing we're going to multiply. We're going to go back over here. We're going to multiply these two together. Okay? We know that we're going to end up with a 2 by 2. So I'm going to get my 2 by 2 ready to go, and I'm going to make him kind of big. And I have 2 rows, 2 columns, so I'm putting like blanks there so that I know that I fill all of them in. Make sense? Okay? So I'm going to have numbers that go in each one of them. This is the hard part. Ready? It's not really that hard. Okay? Okay, I'm going to start with this one, which is row 1. Do you see that? Row 1. And I'm going to multiply those by column 1. You always take the rows times the columns. This is column 1. Do you see that? Row 1, column 1. Okay? Now, what I'm going to do is I'm going to multiply those together, and I'm going to put them in row 1, column 1, which is this cell right here. That's the row 1, column 1 cell. Does that make sense? Okay? This is row 1, column 2 cell, right? Okay, but here's the deal. Here's how we do this. Ready? Okay. When we're multiplying these together, I start by doing 3 times 2, which is 6. And I add that to 1 times 0, which is 0. And I add that to 2 times 1, which is 2. And what is 6 plus 0 plus 2? 8. 8 goes in this cell. Okay? All right, now we're going to do another one. Let me get rid of all my junk here. Okay, now we're going to take row 1, which is this guy, times column 2. Okay, so I start with 3 times negative 3, which is negative 9. I'm going to add that to 1 times 5, which is 5. And I'm going to add that to 2 times 8, which is 16. What's negative 9 plus 5 plus 16? 12. So this whole thing is 12, yeah? Okay, now I'm going to do the next one. This is row 2. I'm going to take that times column 1. Let me get rid of all my other junk here. Okay, row 2 times column 1. Okay, if I take negative 1 times 2 is negative 2 plus 0 times 0 is 0 plus 4 times 1 is 4. And negative 2 plus 0 plus 4 is 2. Yeah?
The last one is 35.
Okay, then I take Last one. See, this is kind of a lot of work, but it's like brainless work. I take row 2 times column 2. -1 times -3 is 3, plus 0 times 5 is 5, plus, no, wrong. 0 times 5 is 0. I lie. Plus
32.
4 times 8, which is 32, so that last cell is 35. Okay, so finally, if you want to write it nicer, 8, 12, 2, 35, that is A times B. Yeah? Good? Makes sense? All right, we'll do a little bit of B times A. I'm not going to do the whole thing because, you know, these take a while. But anyway, it's a 3 by 3. Okay? 1, 2, 3, 1, 2, 3, 1, 2, 3. Ready? 1, 2, 3, 1, 2, 3. Okay? This takes a while except when you're multiplying. So I'm going to take row 1. This is row 1 times column 1. This is column 1, and it's going to go in row 1, column 1. Right? Okay?
And row 1 times column 2.
So I take 2 times 3, which is 6, and I add that to -3 times -1, which is 3. And so this cell is 9 right there. Okay? Now, people get confused because when you're doing a 3 by 3, there's lots of spots and you can put them in the wrong spot. Okay? So let me just test you and see how this works. Let's say I was multiplying this guy right here and this guy right here. Where would that go? This is row 3, and this is, which one did I circle? I circled this one, column 2. Row 3, column 2. If I were to multiply those together, I would have row 3, column 2. So this cell right here would be 1 times 1 plus 8 times 0. What's 1 times 1 plus 8 times 0? 1, right? Okay, so that's where that would go. Happy with that? Makes sense? Not too bad. Row times column, row times column. Okay, good? And that's how you would do that for each one of them. Good? Okay, let's do the last problem, and then we'll just be done. Okay? Matrix multiplication is really good when you have like matrices that look like this. So let's talk about the number of hours it takes. We're removing finish on a chair. We're sanding the chair, and then we're finishing the chair, like we're putting the finish back on it, okay? And it takes that many hours for each one of those things to do, right? Okay? For the table, it takes 1 hour to remove the finish, 4 hours to sand, and 1.5 hours to finish. Dresser, same thing, but different hours, right? Okay? But then I charge a different amount for each one of those jobs, right? $7 for removing finish, $8 for sanding, $10 for finishing. I want to know how much it's going to cost for the chair total, for the table total, for the dresser total, okay? So we make this a matrix, and I'm going to get rid of all the other junk. This is a 3 by 3, right?
Sure.
And it's 0.5, 2.5, 1, 1, 4, 1.5, and 3, 7, 4.5. That's my 3 by 3 matrix. I'm going to multiply him by the amounts, which are 7, 18, 10. And that is a 3 by 1, right? Okay? And I can multiply them together because the middle two numbers are the same, and I'm going to end up with a 3 by 1 matrix. And what that 3 by 1 matrix is going to look like, or going to tell me, is the cost of the chair, total, the cost of the table, total, and the cost of the dresser, total, right? Like I can just do that, okay? So here we go. I'm going to take this row times this column and add them together. So 0.5 times 7 is 3.5 plus 2.5 times 18. 2.5 of 8. 2 times 18 is 36. Half of 18 is 9. 36 plus 9 is 45. Okay, 1 times 10 is 10. Okay, if I add them together, the total cost of the chair is 55 plus 3.5, so 58.5. So $58.50 is how much the chair total is going to cost. Make sense? Okay, now I go back up here. I'm going to get rid of all my stuff. Okay, I'm going to take 1, 4, 1.5 times 7, 18, 10. So 1 times 7 is 7. 4 times 18 is 36 times 2, which is 72. Yeah? 72. 1.5 times 10 is 15. If I add all this together, 79 plus 15 is $94. Yeah? Make sense? Okay. Then I do the last row, which is going to be This one times this one. 3 times 7 is 21. Ooh, 7 times 18 is 70 plus 56, so 126. And 4.5 times 10 is 45. Oh, my heaven's sakes. This right here is 147 plus 45.
190 something.
192.
$192 for the dresser. Make sense?
Sure.
So all three of the sanding, finishing, removing finish, all of the things for the chair table dresser. That's the result that we get by using matrices. Good?
Yep.
All right, so let me go through on the top, 1 through 6. You're going to do all of them everywhere, but 1 through 6 you're using just those 3 matrices. The 1 through 6 shouldn't be too hard, but 7 and 8, don't do more work than you need to, because this is saying determine if B times A, not A times B, B times A, is defined. Like, can you multiply them together?
Oh, you just say if it's
Can you multiply them together, yes or no? If you can, tell me if it's a 3 by 3 or a 2 by 3 or a 2 by 2 or whatever it is, right? Do not actually multiply them together. So it's either going to be yes or no, and whatever the size is if it's a yes, right? You do not actually have to multiply them together.
but like on the top part we do.
So
On the
8
top
is
part you
no.
do, okay? And then 9, 10, 11, 12, those are when you actually have to multiply them together, okay? All right, this is not terribly hard work. It's a lot, but it's not terribly hard, okay? It's okay. 13 is the same thing as what we just got into doing.
Scroll up to example 1.
Scroll up to example 1, like on here, right here,
And like just
and just keep it there.
Yep.
Okay. All right, any other questions before I stop the video?
literally all.
That's literally all. That's all that we have. Okay, use your time to work.
Like on this, I seriously just take the top.
You literally take the top added to the top, or the top subtracted from the top, you know, like each cell.
Alrighty.
Each cell added, each cell subtracted. Okay, good? All right, goodbye people in the video.